Okay, here's warm-up 1R. So let's write an equation in slope-intercept form here. So you got to know that slope-intercept form, that's y equals mx plus b. So there's two components I need here, the m and the b. So the m is the slope, all right? So what I want to do then is choose any 2 points that are on the line. And it really is going to help to use 2 points that are integers if you can have integer coordinates. So I'm looking for points right on the grid. These look pretty good. You could take the coordinates and use the slope formula, but if I have a graph in front of me, I just look at rise over run. So I'm thinking, how far up or down did I go to get from the left point to the right one? Well, I'm going up 2 units, and then my run, I'm going to the right 1 unit. So my slope then is going to be 2 over 1, which is 2. Okay, so there's the slope, and then the y-intercept is right here, and that's the b. So that appears to cross at 3. And now I've got both components, so y equals 2x plus 3. There's the equation. Okay. All right, next problem. We've got a system of equations here. We're going to solve. It doesn't say how to solve this, so there's a number of ways. These are both going to be straight lines. You could graph them, find the intersection. You could do elimination, but you'd want to get the x's, y's, and equal signs and everything lined up first. To me, this one lends itself to substitution. So in substitution, I want to isolate one of the variables in one of the equations. And it just so happens that in the second equation, the y is already isolated. Y is equivalent to 7x plus 2, right? So I'm going to use that to my advantage. So in the other equation, I'm going to replace y with 7x plus 2, okay? So I'm going to replace that y. So in this top equation, I'm going to rewrite this as negative 7x minus 3, and then I'm going to substitute in. And every time I substitute, I use parentheses like this. Okay, and then this is equal to negative 6. And now if you look at this equation, we only have one variable, so we should be able to solve this for x. Okay, so first thing I want to do is get rid of the parentheses by distributing. Okay, and now I want to combine like terms. I've got these two like terms on the left side, so negative 28x minus 6 equals negative 6. All right, now I want to start isolating the x, so I'll add 6 to both sides to get rid of that. So now negative 28x is going to equal 0, okay? And this is a little weird, but yeah, negative 28 times something equals 0. Well, that something has to be 0, right? So when you divide by negative 28, 0 divided by anything equals 0. So my x coordinate then is 0. Okay, now it kind of feels like we're done because we got x, but remember we're looking for an xy pair. These are both lines that are going to intersect, and we need the x and the y, not just the x. Okay, so I'm going to go back to one of the original equations. It doesn't matter which one. I'm going to use the bottom one here. I like that one because the y is already isolated. And I'm going to plug in 0 for x. So 7 times 0 is 0. That means y equals 2. So my solution, you could say what x and y equals. You could also write an ordered pair, right? This would also be the solution. Okay. All right. So that was a system with 2 equations and 2 variables. We can also solve a system with 3 equations and 3 variables. Now you could use substitution on this as well, but I'm going to do this with elimination. Okay. This says eliminate the y's first, and you don't have to eliminate the y's first. But just so I set this up so that my students can compare with my work. So that's what I'm going to go for. All right, so I like to just kind of make myself a note like this, like, hey, I'm trying to eliminate y's, so I remember what I'm doing, okay? I also like to name my 3 equations, A, B, and C, if they're not already named like this. So to do elimination, I need everything lined up, x's, y's, z's, equal signs, and the constants, which they already are, so that's nice, okay? So now what I'm going to do is choose any 2 equations and try to eliminate the y's. So I could use equations A and B, but if I was trying to eliminate the y's there, to get those y's to be opposites, I'd have to multiply both equations. So instead, I'm going to use A and C first. Okay, so looking at A and C, if I want these y's to be opposites so that I can add them together and have them eliminate, I could just multiply the bottom equation by 3. So I'm going to make myself a little note here. So I'm going to leave equation A alone. So just rewrite it as it is. Really helps, by the way, to put the little lines in the z's so you don't confuse them for 2's. All right, and then equation C, I'm going to triple everything. So I made myself a little note here too. So I've got then 6x minus 3y plus 6z equals 3. It's really easy to make little mistakes on these, so it really helps, I think, to be organized with your work and keep track of what you're doing. Okay. Now that I've got this, I'm going to add these two equations together, and those y's are going to eliminate. That's what I wanted to happen. And now I've got 6x plus 6x is 12x, 4z plus 6z is 10z, and 3 plus 3 is 6. Okay. So I've got this beautiful new equation. Let's give it a name. I'll call this equation D, since I've already used A, B, and C. Okay? So now I'm going to repeat that process with any other pair. So I already used A and C. I don't want to reuse those. Again, I could use A and B, but to me it looks easier to use B and C because I need to do less multiplying to eliminate the y's. Okay? So looking at B and C, what I'd want to do is double equation C, because then I'd have 2y and negative 2y. Okay, so I'm leaving equation B alone. Equation C, I'm going to double everything, so 4x minus 2y plus 4z equals 2 when I double everything there. Okay, and now when I add these together, let's see what we get. We're going to get, well, the y's are gone. That's good. So I've got 5x plus 5z equals 5. Okay. Another new equation. Let's call this equation E. All right. So now what I'm going to do, I'm going to use my two new equations as a new system, because both these equations only have two variables and they have the same two variables. Okay. So it's key that you, when you do the elimination, you eliminate the same variable twice. Okay. So now I'm going to put equations D and E together, and I'm going to eliminate again, and I'm going to just choose. Would I rather eliminate the x's or the z's? To me, the z's look easier because I'd have to do less multiplication to get those to be opposites. Okay. I just have to multiply the bottom equation E by negative 2. Okay, and I'm going to leave equation D alone. So this is 12x plus 10z equals 6. And this is going to be negative 10x minus 10z, multiplying everything by negative 2, equals negative 10. Okay, so now I'll add those together. My z's are going to eliminate this time. And now I've got 2x equals 6 minus 10 is negative 4. And hey, I've almost got the x value. And then just divide by 2. X then equals negative 2. Whew. Okay, I got one of the variables. So now I can go back and get the other ones. It's actually a lot quicker to get the other ones. What I want to do is go back now to, you could use one of these two equations, or one of these two. I mean, I know that's just equation D. I'm going to use this. I'm going to use this equation E. So you want to choose one of the equations that only has two variables. So I'm going to use equation E here, the original one, and I'm going to plug in the x value that I just found. And now I should be able to solve for z. Okay, I'm going to add 10 to both sides here. And then divide by 5. Okay, and there is my second variable. Now I've got two of the three, but I still need the y. So the last step is to go back to one of the original equations. Here, I'll kind of separate my work here a little bit. I'm going to go back to one of the original equations. Doesn't matter which one. And I'm going to plug in the two variables that I have. So the simplest one of those three looks like equation B to me. That's the one I'm going to use. So x was negative 2. I don't know y yet. and then z was positive 3. Okay, so I'm just going to the original equation B, plugging those things in, and now I should be able to figure out what y is. So I'll combine those into 1. Now I've got 2y plus 1 equals 3. And we're getting close. Subtract 1. 2y equals 2. And then divide by 2, and I get y equals 1 then. Okay? And you could also write these as an ordered triple, just like you would write an ordered pair. My ordered triple, x is negative 2, y is 1, z is 3. So you could write your answer like that, or you could just say what x, y, and z equal. Okay, that's laborious, and there's a lot of room for little errors. You could also do this on a calculator pretty quickly, or a lot more quickly. And I'll show you how to do that with this problem. Okay, so the same method I'm going to use here. I'm going to write what's called an augmented matrix. Okay, so a matrix, I'm going to write these kind of brackets, and I'm just going to pull the numbers out. So for that top equation, I'm just using those numbers. Oh, by the way, you want these in standard form. So x, y equal sign constants for both equations in order to do this. So the second equation is going to be represented by these numbers. Okay. Now you can do elimination to start eliminating the x's and the y's by hand, but you can also make your calculator do it. So what I'm going to do is go to the matrix menu, and that's it's a little bit hard to see on this calculator, but it's right above this x to the negative first button. There's blue writing that says matrix. So I'm going to hit second, and then it's x to the negative first button. Okay, and I've already got some sort of a matrix put in equation A. A 3 by 4 refers to the rows and columns. So this last problem would have 3 rows and 4 columns. Okay, but this one is actually going to have 2 rows and 3 columns. This one's a 2 by 3. That one's a 3 by 4. So I'm going to go over to edit. I always put everything in slot A, but you could put it in one of the other slots. So I'm going to hit enter on A, and I'm first going to change those dimensions. I'm going to hit 2 enter and then 3 enter. And now I can see this has the right dimensions, and I'm going to input these numbers. So I'm going to hit 4 enter. After everything I hit, I'm going to hit enter, 3 enter, and then when you hit negative 7, make sure you use this negative button, not the minus button. So the negative in parentheses, because we're not subtracting anything. Okay, negative 7, 1, and then negative 2, and then negative 21. Okay, so I got it all in there. Okay, once you get it in there, I'm going to go back to the matrix menu again. Okay, and now I'm going to do some math with that matrix. I can see it's stored in slot A. I'm going to go over to math, and I'm going to choose the ref command. All right, so I want to put this into reduced row echelon form. That's why we're using the button that's ref. So if you go down in math for a while, there's ref. I don't want ref. I want ref. Okay, I'm going to choose that one. Oh, actually, I forgot. Before I should have gone to the home screen before I did this. This is going to put this in my matrix. So I'm going to quit first, which is second mode, or you can just turn your calculator off and back on. Now I'm going to go to the matrix menu, and go to math and ref. So you should have quit after I entered my, I should have gone to the home screen by quitting. So once you're on the home screen and you go to matrix menu, and then math and ref, it should look like this. And I need to tell my calculator which equation to put in, which matrix to put in reduced row echelon form. So I'm going to go back to the matrix menu one more time, and I'm just going to choose the name of the matrix. So for me, that's matrix A. So I'm going to hit enter there. And now when I hit enter once more, it's going to put this in reduced row echelon form. So that gives me a new matrix. Okay, and if you think about what this matrix means, well, hey, the top row here meant 4x plus 3y equals negative 7. So the top row here is going to mean 1x plus 0y equals negative 7. Well, that means x equals negative 7. Okay, and the bottom row here means 0x plus 1y equals positive 7. So in other words, y is going to equal 7. Okay, so in reduced row echelon form, there's your solution, right? The top number is going to be the x, the bottom number is the y. So you could use that process by inputting a 3x4 matrix in as well and using rref to put it in reduced row echelon form. Whew, that was a long one. Okay, see you next time.